Here is our 1.5 day 1 homework. So our first question is just asking us to find the length of AB, which is just the distance between point A and point B. It's also asking us to find the midpoint of AB, which is just the middle of that line segment, and then the slope, so that's the vertical change over the horizontal change. So we'll start by finding the length. So I'll just kind of mark these right here as I'm going to make B our first point, since it's -2, which is more to the left of 5. So this would be x1, comma, y1. So -2 is x1, 9 is y1. And then we have our second point, x2, y2. Okay, so we know distance to be the square root of our horizontal change squared, in which case I would write this as x2 minus x1 plus our vertical change, which is going to be y2 minus y1. To get a better idea of this, I will plot these points, 5, -8, -2, comma 9. So let's make these 5, -8. Oh. Okay, 5, -8. And this one was -2, comma 9. Right? So we can see that right here. I'll go back to here. Okay, that is a little bit annoying. Put this out here. Alrighty. So this would be our point B at or A at 5, comma -8, right? And then B is located at -2, comma 9. So once again, if we're trying to find the distance, I'll use this in red, between A and B, which would look like this, that's the distance between them. I'm not going to use a ruler to count it up. I'm just using the ruler to create a straight line. We will look at the vertical change and our horizontal change, because we derived this using the, let's see the color I didn't use yet, okay, Pythagorean's theorem. There we go. Pythagorean's theorem is a squared plus b squared equals c squared. In this case, our a is our vertical change, so that's from here to here. What's the distance from here to here? Do it like this. And then our horizontal change between these 2 points. So I can just count these up if I'm looking at the graph, but I'll use what we derived here, x2 minus x1 squared plus y2 minus y1 squared. So let's try it out. x2 minus x1 would be 5 minus, what's our x1? -2. And then we'd have y2 minus y1, which would be negative 8 minus 9 squared. So once again, I want to highlight, once I evaluate these x2 minus x1 and our y2 minus y1, I'll show you what those values are. So for example, 5 minus negative 2 is 5 plus 2, which is 7. What that is the change in the horizontal. We're saying from point A to point B, we change 7 units. I'll just write 7 right here. Now if we look at our y2 minus y1, we would get negative 8 minus 9, which is negative 17. So don't worry too much about there being a negative here, because once you square it, it will become a positive value. So we got negative 17. So what that means is that the distance from point A to point B in y values, we have 17 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. See? Now, what do we get when we evaluate this? We get 49 plus, and what is 17 squared? Don't know that one. 289. Let's see if my calculator will get this. Good. 18.38. So this right here would be 18.38, the direct distance between A and B. So I'll kind of highlight this. I'll make this red and delete the rest. The length of AB is, as you guys know, 18.38. I'll just make this black. Okay. Now, we're done with length. Let's look at midpoint. So the midpoint, we know, should be somewhere in this area. Right? It's directly between the two. Now, what we do is we take the average of those two values, the x's and the y's. So the midpoint, I'll just write MP, I'll write this, MP of AB is equal to, and again, it's a coordinate. It's not just one value, it's two values separated by a comma. And that's going to be our x2 plus our x1, or x1 plus x2, in which case we get 3. Okay, 5 plus negative 2 is just positive 3. If we look at our y2 and our y1, we get negative 8 plus 9. Negative 8 plus 9 is just positive 1. So this is our midpoint, 3/2, comma 1/2. So that's essentially right here. Right, this is our midpoint. I'll just call it Q, which is located at, I'll just write 1.5, comma 0.5, right, because that is just the decimal form of this. So we're done with our midpoint. And then finally the slope. This is easy now that we actually put our values here. Our slope, or M of AB, doesn't have to be written like this. You can just say M. And this one you could have written MP equals midpoint is, but I like to denote it this way. We already have it. Remember, it's the change in the vertical over the change in the horizontal. And you'll notice, though, that this slope is going downwards. So we're going to have a negative slope. How many units down do we go? We go down 17 units. So negative 17. And how many units to the right do we go? 7. So we are now done with the slope of the line segment. We are done with this question.